Alright, functions review. We'll start out with number 1, draw a mapping and a graph for the relation. Determine if the relation shows y as a function of x. First, let's start with the mapping. We're going to list all of our x values in numerical order without repeating any. So -3 is our smallest one, 4, 7, and 8. Our y values, we have 2, 2, -9, 5, and 2. So in numerical order, -9, 2, and 5. The way we show which x goes with which y is the arrows. So -3 goes to 2, 4 goes to 2, 7 goes to 5, 8 goes to -9, and 8 goes to 2. Second, we got to show the graph. So we just have 5 ordered pairs. We're going to plot all 5 points. So 8, 2 is over 8, 3, 4, 5, 6, 7, 8, up 2. 4, 2 is over 4, up 2. 8, 9, or 8, -9, over 8, down -9. 7, 5, and -3, 2. So those are our 5 ordered pairs. Determine if the relation shows y as a function of x. That's just a different way of saying, is this a function? That means, is it a function? 2 ways we can tell. One, we can look at the mapping. If I'm looking at this mapping, I'm looking for every x being mapped to only one y. Remember, that's what it takes to be a function. If you look at the 8, 8 is paired up with 2 y values, -9 and 2. That's breaking the rules for a function, so it is not a function. The way we can tell over on the graph that it's not a function is if we use the vertical line test. If I have a vertical line through any 2 points at the same time, then it fails and is not a function. I can draw a vertical line here, and it crosses over both of those lines, so not a function. Alright, 2 more similar problems to that. We have number 2, it gives us 4 ordered pairs and just asks us, is it a function, yes or no, and what is the domain and range? So let's start with domain. Remember, domain is just our x values. So -2, 2, -2, 5. So our domain is -2. We don't need to list that twice. 2 and 5. There's only 3 different values. The range is 3, 5, 6, and 2. So 2, 3, 5, 6. I'm not too picky on the order you listed in. If you list it out of order, I'm fine with that. Is this a function? Yes or no? Again, like up above, we're looking for every x being paired up with only one y. If I look right here and here, -2 is paired up with 2 y values. So not a function. Number 3, similar type of problem. The domain, we just list these x values. -5, -3, -1, and +1. Range is the y values. -4, no, +6, -1, 3. Again, I'm not too concerned with the order you list these in. Is this a function, yes or no? If I look at my -5, he's cheating. He has a -4 and a 3, so that is failing the function test, so it's not a function. Something I want to point out. If you look at this -3, it has 2 arrows coming to it. That is okay. That does not fail the function test. This is not the cause of this relation not being a function. This is the cause for it to not be a function. Find the range values of each function for the given domain values. So we have a function f of x right here. Our domain, these are our inputs, -1, 0, 1, and 2. We're going to plug each one of those in separately, work this problem 4 times, and get 4 separate answers. So if I plug in a -1, 2 times x minus 3, with a -1 in there, multiply that out, you get -1, -2 times, or 2 times -1 is -2, minus 3 gives us -5. This is something your calculator would be very handy for. I showed you a calculator trick where you type in the vertical bar and then x equals the, basically you put that part right there, the mustache brackets in there. So that would be an easy way to do this. I'm going to do it the long way though. So plug in -1 and we got -5. Plug in 0. 2 times 0 is 0, minus 3 is -3. Plug in our 1. 2 times 1 is 2, minus 3 is -1. Plug in a 2. 2 times 2 is 4, minus 3, we get 1. So our range is -5, -3, -1, and 1. Number 5, we have a new function, 4 times parentheses 2x minus 5. We're plugging in 4 new numbers, and we're going to get 4 new range values. So got to remember PEMDAS here. 2 times x minus 5. Plug in a 0. You get parentheses first. So I'm doing this part first. 2 times 0 is 0, minus 5 is -5. Then multiply by 4, you get -20. When you go through all 4 of the inputs, you end up with these 4 range values. I'm kind of skipping over things just to speed this video up a little bit, but there you go. There is your range, all 4 outputs for these 4 inputs. Next, number 6, we have 2 functions, f of x and g of x. Number 6 is asking for f of -1. So we're going to use the f function, which is 5 minus 3x. And we're plugging in -1 as our x. So work that out. 5 minus -3 gives us, change, that's going to give us 8. Number 7, f of 3 plus g of -2. You work that out like it's 2 separate problems. F of 3 means we do 5 minus 3x, which is 5 minus 9, which is -4, plus g of -2. For g of -2, we take the g formula, 3x squared plus 2, and we plug in -2. We have -2 squared. Be careful typing this in your calculator. -2 has to be in parentheses before you square it, or else it'll give you the negative version of the answer. -2 squared is +4 times 3 gives us 12 plus 2, which is 14. So f of 3 is -4 plus g of -2 is 14. If I add -4 plus 14, I get 10 as that answer. Number 8, f of 4. Similar thing here. It's 2 problems combined together. F of 4 is, I'm going to work it up here where I have more room. Take the f function, 5 minus 3x. Plug in a 4. That gives us 5 minus 12, which is -7. G of 3 gives us 3x squared plus 2 plug in the 3 here from the g of 3. We're going to get 3 squared, which is 9, times 3 is 27, plus 2 is 29. So now, if I do f of 4, which is negative 7, minus g of 3, which is 29, I end up with negative 7 minus 29, which gives us negative 36. Number 9, simplify each expression. When it says simplify, we are shortening this expression down as small as we can using the distributive property. And then combining like terms. Look at that perfect handwriting. Number 9, we have 3 different x terms. We got negative 6, 4, and negative 3. So just combine all those. You end up with negative 6 and negative 3 is negative 9, plus 4 is negative 5x. Number 10, we have a 6a and a negative 6a. That cancels out to give us no a's. And then we got a 2b, and 5b is 7b. Number 11, we have some distribution going on here. We have to distribute first. Multiply this 4 times both terms in the parentheses. So 4x plus 8. We have a negative 5. Careful with the negative there. That gets distributed to those parentheses. That gives us minus 15x minus 30. Now I can combine like terms.
Can I see your iPad?
No iPad. 4x minus 15x is negative 11x. Positive 8 minus 30 is minus 22. There's my simplified version. And number 12, another distribution. We have a negative 2 getting distributed. Negative 6x minus 10. And then carry down the minus 4 at the end. I have no other x terms except negative 6x. I do have 2 constants. I have a negative 10 and a negative 4. That gives me negative 14. So there is that. All right, and the real problems now. These are the fun ones. Domain and range. This is number 13, 14, and 15. We're just finding the domain and range of each one. So let's start with domain. I know domain is my x values. The x values go from left to right. So I'm looking at this graph, figuring out where my 2 left and right boundaries are, if there even are boundaries. This, I have a boundary here and a boundary there. The entire graph is in between those 2 boundaries. So I need to figure out where they are. This is negative 1, 2, 3, negative 4. This is positive 2. So the entire graph is in between negative 4 and positive 2. So I'm going to say my domain is negative 4 is less than x is less than positive 2. I always go back and double check to see if any equal to's belong with my less thans. It looks like it does equal the line there, and it does equal the line there. So I'm going to put equal to's. I know it's going to equal because there are no open circles there. The only time it doesn't equal is if there's an open circle. That's your domain. The range is the same thing except bottom to top. So I need to look for bottom boundaries, which this arrow says there are no boundaries because it goes on forever, and top boundaries. Again, there are no boundaries. It goes up forever. If it goes up forever and down forever, my range is all real numbers. Next one, we have another little squiggly line here. Domain, again, x's left to right. My left boundary is negative 4. Again, my right boundary is positive 5. So my domain with 2 boundaries is negative 4 less than x less than positive 5. I see solid dot on that left boundary that is equal to, and I see a solid dot here, so that's equal to. Range, bottom to top. The lowest this graph goes is -2. The highest it goes is 4. So the range goes from -2 to 4 with a less than, y, less than in between. Look at our dots. I see solid dot on both boundaries, so both inequalities get a less than. Next one, we have a little curvy line, but I notice this arrow means it goes on forever. So my domain has no starting point. There is not a boundary anywhere over here because it continues on and on and on. I do, however, have a right boundary. 1, 2, 3, 4 at +4. So my graph starts at +4 and it includes every single x value that is to the left of that +4. So the entire graph is less than 4. The way I say that with one boundary is all the x values are less than 4. With one boundary, we have to put the variable first, whether it's x or y. The x, in this case, has to go first. That's different than if there's two boundaries like on the previous problem. I want to double check my less than to see if there should be an equal to. I see a empty dot here. Empty dot means it is not equal to that boundary, so there is no underline under the less than. My range is bottom to top. If I look at the bottom, there is no bottom boundary because that keeps going forever. But there is a top boundary. The top boundary is up at +3. All of the y values, the entire graph, is below that mark. So all of the y values on this graph are less than 3. Let's go look at the boundaries, see if I get an equal to. This little boundary up here is the curve where it changes directions. There is no empty circle there, so it does equal. Well, my pen's not there. It is. My pen wasn't working. It does equal 3. So there's your range. Towards the end of the night, the concession stand sold out of every item except for 8 hot dogs. They have $135 in the cash register, and they want to earn as much money as possible trying to sell all of the hot dogs for $3 each. Sorry, I was misreading that. So this concession stand is trying to make as much money as possible. They start out with $135, and they're making a little bit more money selling hot dogs for $3 each. This is the equation I'm thinking in my head. So this is the function that is described in that equation. Number 16 says, what is a reasonable domain for this function? Domain is x values. So what I'm thinking is, what possible numbers could get plugged into this x? Well, that x is the number of hot dogs they're selling. If they sell 1 hot dog, we're doing 135 plus 3 times 1. If they sell 4 hot dogs, 135 plus 3 times 4. So the x is the possible amount of hot dogs that they can sell. Well, they could sell 0, that's the lowest case, or they could sell up to 8, that's the highest case, and any whole number in between. They can't sell decimals, they can't sell fractions, they can't sell negative numbers, so they can either sell 0, 1, 2, 3, 4, 5, 6, 7, or 8. So the only possibilities. Is 141 a reasonable range value? Why or why not? Well, the range, the output, what I would get here is the money they make. If I know how many hot dogs they sell, X, then I know how much money they're going to make, which is our Y. So can they make $141? Well, if I'm looking at all of these possible inputs, each one of those are going to add $3 to their current total of 135. So if they sell no hot dogs, Let me move this over here. F of x equals 135 plus 3x. If they sell no hot dogs, they're just going to stick with 135. If they sell one hot dog, they're going to make $3 more, which is 138. 2 hot dogs, $3 more, which is 141. So yes, 141 is a reasonable range value. So I'm going to say yes, because selling 2 hot dogs earns them $141. 18 is 160 a reasonable range value? Why or why not? What I'm trying to think is it possible for them to earn exactly $160? So I see this pattern going up by 3s each time, each hot dog they sell. I'm going to continue that pattern. So if they sell 3 hot dogs, 144. 4 hot dogs, 147. 150, 153, 156, and 159. Can they earn $160 exactly? No, they cannot. The most they can earn is 159. So this is not a reasonable range value because the most back up. They can earn is $159. Our last two here, number 19 and 20. 19 says to draw an example of a graph that does not represent y as a function of x. Again, we see this terminology, y as a function of x. That just means that it's a function. Y depends on x. So, if it does not represent a function, then it cannot pass the vertical line test, which means it's got to kind of loop back over itself. So if I do a graph that is like that right there, then this fails the vertical line test. I can show a vertical line right here that has 2 corresponding y values, so it fails. This is not a function. Number 20, draw an example of a graph that shows y as a function of x. That means it is a function. So I need to make this graph where there is no possible vertical line that crosses the graph twice. So there's a million right answers you could have here, but I'm going to do a little squiggly line like that. You cannot draw a vertical line anywhere on that graph that will cross my blue line twice. So this is a function, this is not a function, and that's it. Good luck.